Hello friends, welcome back. Hearty welcome to you. In this session, let us look at an interesting similar triangles problem. So here is the problem. Let's try to solve it together. We have been given that ABC is a triangle with vertices A, B and C, and also PQRSTU are points on the sides AB, BC, CA respectively, such that US is parallel to BC, QT is parallel to CA, and PR is parallel to AB. So this is the information given to us, and we have been asked to prove that PQ by BC plus RS by AC plus UT by AB is equal to 1. So, how to start this particular problem, how to go ahead with this? First, we know that whenever you see parallel lines, immediately we have similar triangles there, either by basic proportionality theorem or by a similarity. Now we have similar triangles here, so let's try to identify those similar triangles. I'll go ahead and start with the similar triangles. First, starting with A, I know that US is parallel to, let me write it down, US is parallel to BC. That gives me AUS is similar to ABC. What else I can find out? Similarly, I have QT is parallel to AC, so I can say QT is parallel to AC. That will give me, if I look from here, BQT is parallel to BCA. Similarly, if I take PR parallel to AB, PR parallel to AB, so we are starting from PR parallel to AB, I have CRP similar to CAB. How we got this? We got this because we know that if two lines are parallel to each other and they are in a triangle, then you know that they form similar triangles because parallel lines corresponding angles are same. So you know that angle BQT equal to angle BCA. Similarly, angle BTQ equal to angle BAC. So let's just try to represent that and see what we have done. So what I will do, I'll start just with the angles. Let us say this angle is theta, this angle is theta 1, this angle is theta 2. So if angle ABC is theta, then also angle RPC is also theta. We know that. Similarly, if angle ACB is theta 1, angle TQB is also theta 1. Okay, right. What else I can tell? I can tell that if angle ABC is theta, angle AUS is also theta because corresponding angles are same. Similarly, if angle BCA is theta 1, angle USA is also theta 1. That's good, interesting. What else we can say? We can also say that if angle BAC is theta 2, then angle PRS is also theta 2. That's good. We had left with the angle UTQ. What is the angle UTQ? That is nothing but equal to angle BAC because QT and AC are parallel lines. So this is nothing but theta 2. So we have said that US parallel to BC, AUS where you have angles of theta and theta 1 base angles is parallel to again theta and theta 1, right. Now one thing we have to understand is, are these only the similar triangles we have, or is there any similar triangles? That is what we have to work on to. Let us see that. US parallel to BC, AUS is parallel to ABC. Not only that, if you observe a little bit carefully, you can also see that it is similar to XPQ, because if you take XPQ, the base angles are theta and theta 1, which is nothing but that of ABC, and which is also that of AUS. So can I say now that this is also similar to XPQ? Similarly, here you can see not only BCA, that is also similar to, where are we? BCA. That means angle of theta 1, theta 2. So BCA is also similar to XSR. Also CAB, CAB is also similar to XTU. So this is the information we have got. So let's just write it down. Okay. And by the way, once we know that these are the triangles which are similar, we have to look into what we have been asked, and we have to see where we will find that information. Based on that, we have to pick the similar triangles. When the first you have seen this problem, you will immediately think that okay, AUS and ABC will solve this problem, because evidently it is visible that AUS is similar to ABC, but you have to be little bit careful to understand that it is also similar to XPQ, because AB and P are parallel lines. Similarly, AC and QT are parallel lines. So XPQ is also similar to ABC. Similarly, XTU is similar to CAB. Similarly, XRS is similar to BSC, or I can say XSR is similar to PCA. Now, what information we have been asked to find out? We have been asked to find out where we have that information. We have PQ and I have PQ here. I want RS, I have RS here. I want UT, I have UT here. That means I have to consider the third set of similar triangles to get my numerators. Then if you look at the denominators, you have BC, AC, AB. That is nothing but equal to here BC, here AC, then I have AB. So that means I will be considering the last two similar triangles. I may not be need them. So let us write down what we need to do. Okay, I'll write it down here. We know that ABC is similar to XPQ. I'll write it down because we finalized that these are the similar triangles we will use to solve this. Next one is BCA is similar to XSR. The next one is CAB CAB is similar to XTU. Okay. Now I see that in the answer I need PQ, RS, UT, which I have in this triangle, and I want AB, BC, CA. That is also available now with me on the left hand side. So once you know these triangles are similar, we know that the sides should be in proportion. So let's put them in proportion and see what it becomes now. If I start from here, can I say XB by AB is equal to PQ by BC? Seems to be interesting. That is what I want. PQ by BC. Very good. Equal to QX by CA. Similarly, if I go to the second one, I have BC by X. Okay, I'll go in the reverse direction. I'll start with this. So I will say XS by BC equal to SR by CA equal to RX by AB. So that is one set of information. You know that we have done all the hard work and found the similar triangles which will give us the solution. Now we have to prove something to be added and equal to 1. So I will get it only when I take that if the triangles are similar, then the sides should be in proportion. So let's go ahead and write down this one too. The last one, it will be xt by ca equal to tu by AB equal to UX by BC. Let me look at that. XT by CA equal to TU by AB is equal to UX by BC. Remember, once you have kept the similar triangles exactly same, how you have to put them? The angles are same. You can look there. Angle at A and the angle at X are same. Angle at B and the angle at P are same. Angle at C and the angle at Q are same. Once I have done that, I don't need the figure anymore. I can directly go AB by XP, BC by PQ equal to CA by QX. That's how we have written them. Now let's try to understand what we need to add. What we need to add? I need to add this one, PQ by BC, to what? RS by AC, and that I have to add to what? TU by AB. So these three things I have to add. So let me go ahead and add them. Okay, I will write it down. I will say PQ by BC plus RS by AC plus TU by AB. I have to prove this is equal to 1. Now what we will do is, you can see here all of them have same denominator, AB, AB, AB. So all of these I can convert them into one denominator. Which denominator? Either it can be, if this is in PQ by BC, I can equate this as QX by AC, so that I can have a denominator of AC, and I can prove somehow that the numerator is AC, then AC by AC will become 1. So what is the idea? The idea is to convert them into the same denominator, and I am going here to prove that AC by AC is equal to 1. So what I will do now, I will convert all my denominators into AC. So PQ by BC is nothing but equal to QX by CA. So I will write down QX by CA or AC plus RS by AC plus TU by AB. That also I want to convert into a denominator of AC, but I have here, so I can write down XT by AC. Very interesting. We have everything with AC. The only problem is, now I have to prove that whatever the numerator I have, that should be equal to AC. So QX plus RS plus XT by AC, I have to prove that it is equal to 1. Now how to do that? For that, let's go back to the diagram. Now I have to prove that QX plus RS plus XT equal to AC. If you carefully observe, you will see that QCSX is a parallelogram. QCSX is a parallelogram because it has two pairs of parallel lines. So can I go ahead and say QX equal to SC? Because you know in parallelogram opposite sides are equal. Similarly, if you look at this quadrilateral XRAT, that is also a parallelogram. Again the same logic. Why? Because you have two pairs of parallel lines and opposite sides are equal. Now our problem is solved. So I'll go ahead and say wherever QX, now I want to transpose it to AC because I want to prove AC by AC equal to 1. So QX is equal to SC on AC. So I will go ahead and say this is nothing but equal to SC plus RS, I will keep as it is because it is already there in AC. Then I have XT. XT is nothing but equal to, this is what we are trying to do. XT is nothing but equal to AR because XR AT is a parallelogram. So can I go ahead and say now that's nothing but equal to AR and divide that with AC? You can obviously see that AR plus RS is AS plus AC is AC. So this is nothing but equal to 1. How we have done that? AR plus RS plus SC. You can see AR plus RS plus SC equal to AC. So AC by AC is equal to 1. That's how we can solve this very interesting problem. A little bit seems to be, you have to put a little bit of effort to understand how to resolve this problem. So let's go ahead and summarize this before we wrap it up. Okay, here you go. We have been given that ABC is a triangle in which PQRST are vertices. ABC is a triangle with vertices ABC, and you have points PQRSTU are on sides BC, CA, AB respectively, such that US is parallel to BC, PR is parallel to AB, and QT is parallel to AC. We have to prove that PQ by BC plus RS by AC plus UT by AB equal to 1. Now this problem to solve, we have taken two steps. The first step is, we know that whenever there are parallel lines, we have similar triangles. So we have to identify the similar triangles. To do that exercise, in first step, we know that it's very evident that US is parallel to BC, so AUS is parallel to ABC. Similarly, BQT is parallel to BCA, CRP is parallel to CAB, but with that we are not going anywhere because what we want to prove seems to be little bit different. So we did a little bit of homework and we checked that ABC and XPQ are also similar to each other because PR is parallel to AB and QT is parallel to AC. So we got three more similar triangles for ABC. So ABC is similar to XPQ, BCA is similar to XSR, and CAB is similar to XTU. We have taken these triangles because we see that in these triangles we have our numerator and denominator, whatever we want to prove. Once we know that, now whenever I want to add the ratios, first I have to find out what is that. For that, we know that if triangles are similar, the sides are in proportion. So we have seen how this proportion looks like. And we are able to understand that we have been asked to add these three, PQ by BC, SR by CA, and TU by AB. Now you know that we want to convert this into one denominator. It can be AC or BC or AB. So we have leveraged whatever the information we have and we have converted them into denominator of AC, and we have seen that there are a couple of parallelograms which helped us really to solve it and make it as AC by AC equal to 1. So when we have seen that it's nothing but QX plus RS plus XT by AC we have to prove. We know that QX equal to CS and also we know XT equal to AR because they are parallelograms. So with the help of which we are able to prove AC by AC equal to 1. I hope you liked this problem. That's an interesting problem with respect to similar triangles. See you again with one more interesting problem. Thanks for visiting. Bye for now.